Hi there, my name is Jessa Ellenburg and I work for 2B Technologies in Boulder, Colorado. We make instruments to measure air pollutants, and I'm excited to talk to you today about our last decade using those instruments for outreach and education with students and the public. First, I wanted to give you a little background on 2B Technologies as a company. We specialize in miniaturizing instrumentation used to measure air pollutants. In the picture, you can see the bottom instrument is a traditional ozone monitor, and the top two are instruments we've developed to miniaturize that ozone monitor. We have also worked to drive the cost down of these monitors to make them more accessible to student and community groups. Because of the miniaturization and cost reduction of the monitors we've developed, we were able to start using them in outreach programs to schools. Before we go any further, I'd also like to take a moment to talk about sensors versus instruments and the distinction. Instruments measure air pollutants based on a fundamental principle and are often designated FEMs, or Federal Equivalent Methods, which is an EPA stamp of approval saying that you've met certain criteria in the monitoring of a specific pollutant in terms of accuracy and precision. Sensors, on the other hand, can be thought of similar to your nose. They can detect the presence of pollutants and their approximate concentrations, but sometimes they can't tell the difference between pollutants. In the sensor world, that's called a cross-sensitivity. Due to their small size and low cost, they have become very appealing to community groups and educational groups in air monitoring, but they have some limitations. In 2009, we started our first outreach program. Back then, sensors weren't really a thing yet. So we used the 2B Tech Ozone Monitor in our first project, which we called the Global Ozone Project, or GO3 project. We sent ozone monitors to schools around the world, and the students set them up for stationary ozone monitoring. The data were uploaded every 15 minutes automatically, and the students were able to see the data online. We got feedback after a few years on that project that the students really wanted to take their measurements mobile. They wanted to do some exploration. So we decided to pilot a mobile monitoring program with students, and that was the AQTreks project, which we started in 2015 through an NIEHS grant. That project was also instrument-based, and it allowed students to measure black carbon and ozone mobily. The success of that project encouraged us to keep going, and we started the AQTreks project in 2016 and decided to evaluate the idea of using a sensor suite for that project to reduce the instrumentation cost. Here you can see a picture of the GO3 instrument package we sent to schools around the world. We sent them a weather station, ozone monitor, and computer for data uploading. We displayed the data on Google Earth with 3D bars. As you can see, the students could plot max, min, and current values and compare them to other schools' measurements. They could also graph the measurements online. And this is just a picture I threw in, one of my favorites, the first GO3 school ever in Estes Park, Colorado, and they were in the process of calibrating their ozone monitor. After working with students and teachers for many years with the GO3 project, we started the mobile pilot project of AQTreks. We used instrumentation in this project as well versus sensors with a 2B Tech FEM personal ozone monitor and an 8th Labs microwave for black carbon. Once the students were done with their data collection experience, they came back into the classroom, and our software compiled the data from the two separate instruments and uploaded to our social network where it was displayed in 3D maps for the students to see, and also they were able to write a blog describing their data collection experience. The AQTreks pilot project was an overwhelming success. Teachers and students absolutely loved the project and their ability to explore any area of interest to them. So we took the next step and created a sensor suite, which we called the personal air monitor. We wanted to reduce the cost of instrumentation in the project to reach a wider audience because the instrumentation we had used was quite expensive. In AQTreks, it was around $10,000 per school. So we wanted to reduce this cost and get more students involved in the actual process of data collection. We were able to do that by allowing the PAM to broadcast Bluetooth data to any smartphone within range. So even with just one device per school, many students were able to participate in the live data collection process. The data are displayed on the smartphone app for AQTreks in maps and graphs. And if the students choose, the data can be uploaded to our website for display on Google Maps. Last year, we were able to write a paper and reflect on our experiences with stationary and mobile outreach programs. I put together this slide to compare and contrast the advantages and disadvantages of each project that we found. I thought it might be helpful for people who are designing a project, some food for thought, and what we experienced in our journey with these programs. I'm not going to go over all of the slide, but I thought I'd point out a few highlights, and you can look at the rest of the slide in the recording. The scientific value and student engagement were pretty interesting aspects of each project. So the stationary monitoring project turned out to be very scientifically valuable. We used a high quality instrument. We were able to control installation to an extent and maintenance and calibration. So that resulted in high quality measurements. The mobile projects, however, are a little bit more difficult for scientific value, as the mobile measurements are harder to assign scientific value to in the wider community. But as far as value to the students and the schools themselves, the measurements were extremely valuable, especially in cases when schools found high carbon monoxide readings from broken boiler and high carbon dioxide readings in their classrooms. From a student engagement standpoint, the stationary monitoring project resulted in high student engagement at first, but then declined as the project went on because there was nothing kind of new or exciting in the measurements themselves. So I would say that the stationary monitoring was high scientific value, but relatively low student engagement. And the mobile monitoring, perhaps not such high scientific value for the community at large, but very relevant for the kids themselves and super high student engagement. We found full class engagement and participation, and teachers reported that it was a perfect project, exploratory project for their students. As we were thinking about the disadvantages and benefits of mobile versus stationary monitoring, we decided, well, maybe we should just combine the two. So we made an enclosure for the PAM that you can see on the left, in the picture on the left, and that can be placed outside of a school and used to make stationary measurements generally. And then if the students need to do a class or an exploration, they can take the PAM out and do their exploration, return the PAM to the box, and continue their stationary monitoring. On the right, we have an ozone monitor inside a box with a PAM. So that's just PAM measurements plus FEM ozone. This is a relatively new development that we are piloting at a few schools right now. One thing that we've been real sticklers about throughout this entire process with outreach to the community has been data quality, especially when we decided to create the PAM, the sensor suite, and start using sensors. We felt it is generally somewhat irresponsible to send sensors out into the community without people really understanding how to calibrate and maintain them. So our experience with the Go3 project showed us that it's very difficult for teachers to maintain a monitoring station. For that reason, we decided on a rental model for the PAM with calibration checks between rentals. We found that a 3-week rental is the sweet spot for the PAM being used, plus them having enough time for their studies. With the calibration checks between rentals, community members and students could feel confident in the measurements that they were taking. Another thing we wanted to provide the students that were using sensors was a way to do a sanity check, if you will, on their data. So in the AQTreks app, we actually pull in data from the nearest regulatory station to compare side by side with the PAM measurements. So you can see a screenshot of that. And that way the students could make sure that it was the correct order of magnitude they were looking for. And we also give the students location information for the station that the data are coming from. And theoretically, a student could go to that station and do a quick walk-by calibration of their sensors. When we were thinking about the concept of a walk-by calibration, we realized that often regulatory data are only published as hour averages. So you wouldn't see the real-time data from the regulatory station that you would need to see to do a true calibration with the PAM sensors. So we thought, well, we make all sorts of FEM instrumentation, so maybe we should combine all of that in a box and create a community sensor calibration station, which we ended up calling AQ Sync. So the concept with that is that we'll publish data every 10 seconds, and you can do an on-the-fly calibration of any sensor, not just our PAM, but any sensor that a community is using to do a check of the sensor calibration. Over the last 10 years with our outreach programs and development and refinement, our central goal has always been the same: to get community members, students, the public involved in air pollution monitoring and get the tools that they need into their hands to measure in a responsible and accurate way. All this development has caught the attention of regulatory agencies, the EPA, and most of all, Michael Ogletree with the City of Denver, who said to us one day, well, I just want to try all of this stuff, and when can we start? So Michael has been using the PAM in Denver public schools to look at asthma triggers and reducing exposure to asthma triggers. And he's also putting PAMs on some fleet vehicles. So you can see that in the picture, that little white car topper, there's a PAM in there. And using AQ Sync stations to calibrate the sensor data on his mobile fleet. Thank you so much for participating in my presentation today. I have absolutely loved this journey over the last 11 years, creating and refining these outreach programs. And I hope so much that if you have any questions about developing your own program, or if I can help guide you in any way, I hope that you'll reach out to me. Thank you so much.